Okay, so in this little video, I'm going to demonstrate charging and discharging a capacitor through a resistor. And so I'm going to start out with this very simple circuit. I'm just going to have the capacitor sitting on the breadboard, and I'm going to be using a voltmeter to measure the voltage across it. And then the very first experiment, I'm going to start out with a capacitor that's initially uncharged, that is, the voltage across it is 0. And you're going to see that I'll just take a battery and I'll just quickly connect the battery across the capacitor using the rails on the breadboard. So let's just do that first. So I'll just connect this just briefly, like that. Whoops, I'm missing a wire here. Okay, I need to connect the top lead of the capacitor to that voltage rail. There we go. All right, and you can see that the capacitor is now, it's charged up. It's sitting at a voltage of 6.2 volts, which is actually our battery voltage. So now I'll pull away the battery. And what you can see is that the voltage across the battery stays at 6.2. If we let it sit there over time, it would gradually go down to 0, but it would take quite a long time to do it because we have charge stored in the capacitor, and there's no load on the capacitor. We're not removing that charge, so it just sits there at 6 volts, and that's because the voltage across the capacitor is proportional to the charge in it. Okay, so what I'm going to do now is I'm going to discharge the voltage from the capacitor. I'm going to go and show you this circuit here, where I'm going to connect the one terminal of the capacitor through a resistor to ground, and that's going to cause it's going to cause current to flow as charges go from the capacitor through the resistor down to ground. And so I'm going to do that first using a relatively small resistor. It's a 100 ohm resistor. So there's that resistor. You can see that keep an eye on that voltage there. So once I connect it, you'll see that it discharges, and there it is. It went pretty quickly. I mean, it happened in, something like a second, right? But it happened quite quickly. We're down to 0 volts, all right? So now I'm going to charge it up again, and I'm going to repeat that experiment, but when I discharge, I'm going to use a bigger resistor. So we'll charge it up again. There it is. And now I'm going to use a 10 kilo ohm resistor. So I had 100 ohms before, and now I have a much larger resistor, right? From 100 ohms to 10,000 ohms. And what that means then is I have much smaller current, right? Since I have a smaller current, it's going to take longer to pull those charges out of that capacitor. So let's go ahead and take a look. As we discharge this, you can see it's much more gradually going down. And then we'll even see that it slows down the discharge as it gets down towards 0. See, it's actually slowing down here now. So what's happening is that the charge that's in that capacitor is being emptied or removed from the capacitor because we've created a loop and we've got current flowing in it. All right, and we'll wait till that gets down. Okay, what I'm going to do at this point is just take that capacitor and connect it down to ground so I can sort of quickly get rid of any excess charge. All right, the next thing I want to do is hook up this battery again. But instead of hooking up the battery directly to the capacitor, I'm going to charge it up through a resistor. So I'll show you the circuit that I've got. It's going to be this circuit here. Whereas previously we just connected the battery directly across the capacitor. Now I'm going to connect the battery through a resistor to the capacitor, and then we'll look at the voltage. Okay, so you see here's our resistor. It's a small 100 ohm resistor. Keep an eye on that voltage. And you can see it charged up pretty quickly, good part of a second. Okay, and I will get rid of the charge on it by shorting it to ground, back to 0. And now I'm going to do the same thing, but I'm going to use this bigger resistor. I'm going to use a a 10K resistor. So once I hook it up, we're back to this circuit. I've got a much bigger resistor, smaller current. All right, so it's going to take longer to charge it up. Let's go ahead and connect it. And you can see that the voltage is sort of taking its time. And here it seems to be taking longer and longer now to reach this 6.2 volts. It's actually going to be approaching that asymptotically. Okay, so that's enough of that video.